way we cool the building, unlike a legacy or traditional data center, this is a two-story data center. And on a legacy data center, you would have computer room air conditioners on the floor with the racks and the servers. And what happens there is, it's sort of what I'll call a law of diminishing return. As it gets hotter upstairs, as you add more density to your servers, you have to start taking some of those racks out of that productive space and adding more computer room air conditioners. So you get a diminishing return. You get less and less servers up there and less racks. So we've separated it to a two-story design. So we're cooling from the first floor. These are large trained commercial air handling units. They're the largest ones that you can get that you can bring in 3 pieces over the road. That's why we have the overhead doors on the other side of this room. They're all tied together in a bay. A bay goes the width of the building, and each tenant space is a bay or multiple bays upstairs. We push the cold air up together. They're all tied together so that you have N plus 1, your required amount, plus 1 additional as a redundant. And if any one were to go down, the other 3 can pick up. Then, if you look at the jacketed ductwork right here above this pipe, it goes up again. That's pushing up to the raised floor, the underside. If you look right above you here, that's what's pushing up through. There's one of the louvers, since this bay hasn't been filled out yet. But if you were to walk to each end of the room here and look up, the last 12 feet beyond those diagonal shear braces for the structure is open to the second floor. And that hot air goes up through the racks, cools, comes back down, and goes back into these units. So when you're standing in here, you're actually standing inside the air conditioning. You're in the return air plenum. This is all part of the air handling system. These units have Mervate filters in them. One set of filters is about $40,000 per unit. You have to replace it like once a year. But they're very good units. They're very efficient because we use chill water cooling versus air cooling, which is a much more efficient way of doing things. If you notice on the outside of the building, the louvers, we have the higher and the lower louvers. The lower louvers, we can actually bring in free cooling, cool air in the colder weather. We have to humidify it because the servers and the racks are very sensitive. And in fact, the last tour that was in here got very loud. The compressors came on, the humidity control came on. There's copper piping along the wall, and it has little heads on it, little nozzles. And it's like if you've ever been to Disney World when it's really hot, they spray on you. Well, that's you walk in here and it's a mist. It starts to feel like a spa in here. Because we get that free cold air in the winter, but that air is very, very dry, and the servers don't like that. We have to maintain the right level of, we actually control what we call dew point rather than humidity, because that's a true measure of the moisture in the air versus humidity is relative to the actual temperature that you're measuring it at. So the servers don't like that. You know how you walk across the carpet at home in the winter and you go to touch something that shocks it? Well, we can't have that happen upstairs. You would probably put servers out of business. So that's, for the most part, how it works. On the other side of this wall is another 50,000 square feet. You've only been in half of the building. There's another 50,000 square feet upper and lower area that is ready with 8 more bays on that side. There's 8 bays on this side. A structural bay, 30-foot wide structural bay, is what we lease out upstairs. We lease out in multiples of a bay unit. Is we can't cut the building in this direction because of the way the air flows. So we're really a wholesale model of data center. We don't manage people's racks and servers. We provide the cooled area, the raised floor. You're going to be up there shortly. There's some other amenities we have up there, but for the most part, we're a wholesale model.
This is their expansion space. This board is meant to illustrate the traditional data center design moving into power loft design. This is a single-story design, and you can see these are racks of computers and servers, and this is your IT production area. In the traditional design, you've got your cracks along the walls are distributed amongst the IT servers, and as you get hotter and draw more power, you've got to add HVAC onto that raised floor and to cool these servers. As you get more requirement, more dense, and thus hotter, you have to have even more HVAC pushing air in the traditional model. So you lose production area. You lose the ability to run your servers, your IT load. You run into some inefficiencies with this design. In the two-story design, everything happens on the ground level from an HVAC standpoint. So this is your IT load, this is where your servers, your production area is. As you require more power and thus produce more heat, all we do is down below add air handlers, pushing air through. Nothing ever occurs on this raised floor area that is mechanical in nature. So there's no HVAC up here. Everything happens below. So you get the scalable density is a benefit to this design on one hand. On the other hand, it's secure. So you've got all of your IT equipment upstairs. If you have someone with a tool belt, he's going to do all his work downstairs. Never enters the critical portion of the data center. So you can see we've got the perforated floors. Those can be moved around, whatever the end user wants to design. Where the racks go, depends on their application. Air flows through, goes out either into the building. You can see behind you there's the big openings. That's where the air goes out. Goes around the